Hello and welcome to the lecture on section 10.1 to 10.4, which deals with production. How do we make the products that we're going to provide to customers? Talk about a variety of issues that come into play when you look at doing manufacturing, one type of production. So first, a little bit of definition. So production is kind of a big term that really covers everything that is possibly produced. And manufacturing is a subcategory of that. So those two words aren't synonyms of each other. So one type of production is converting inputs to outputs. So converting lumber into furniture, converting plastic pellets into an iPhone case, whatever the situation might be. There could be services involved. So that's labor that you apply some useful benefit for a customer. So that could be services. It could involve agriculture. That's converting seeds and soil and water and creating food. And then there's also manufacturing, which is factories and that sort of thing that we normally think of. So a couple different types of production. One is process manufacturing. That's where we take a raw material and break it down into its component parts. So here we see a sawmill. So it's taking a tree that has been fallen, so a log, and turning it into different types of lumber and wood chips that'll be turned into paper and a whole variety of things that come out of that particular tree that we find useful. Other examples would be petroleum that's refined into different kinds of products, iron ore, which is dug up and turned into different kinds of products, or some types of agriculture like raising hogs and turning them into different types of food. Another type of production is an assembly process. This is where you take a variety of different kinds of materials and components and pull them together to make a product that didn't exist before. This is an example of a chair factory. So there's a variety of different materials coming together, and there are craftspeople that are able to work on those materials and pull them together. There are some factories that employ continuous production where it is very costly or nearly impossible to close the factory down to stop it. It makes more sense just to keep it going all the time. Anything involving molten metal, as the picture shows here, is an example of that. My dad used to work in an aluminum die casting factory in Chicago, and they operated 24/7 because they had cauldrons of molten aluminum and zinc that they turned into parts for cars. So they could never stop, or the metal would harden. There's a big move right now towards more intermittent production processes, so short runs, manufacturing to customer order rather than to planned inventory. So this is a whole effort. You might have heard the term lean manufacturing, which is to try to hold as little inventory as possible in the business and just make what you need when you need it. It can create a lot of efficiencies and help with cash flow. So that's a big trend. There are a lot of times companies will use programmable machines. So a very, very flexible manufacturing operation. So a little bit about production methods. So mass production. So if you think about early production, maybe being kind of like a craftsman making a single product by himself, making a piece of furniture or something that's almost creating art in many ways. Mass production is the opposite of that. It's a whole bunch of people doing very little parts of one process that together makes a whole product. So there's specialization of labor. So each worker does one specific task. The benefit there is that you can get very, very good at that task and very efficient. The downside is that's a pretty horrible job, right? To stand there and do the same thing all day long is not a job most people would want. So there's pros and cons to that. So in production methods, another way to do things is to increase productivity, and I would also say increase quality in some cases through mechanization. That's where you have machinery. It could be robotic machinery or just mechanized processes that do the work in place of a human doing the work. A lot of times it can be done more precisely, and a lot of cases dangerous jobs that had risks associated with them can be done much more safely by a machine than by a human. So standardization is a process to go through your product line and make sure that you're using as few parts as possible that are interchangeable and used in a bunch of different products. For example, say you're assembling benches and picnic tables, and you have 10 different, slightly different washers that you have to maintain and keep track of and keep in stock and purchase them and inspect them, all of that, where maybe one or two washers would suffice for all of those products. Now the benefit is you don't have to track as many items. You're going to be purchasing more of a fewer number of items, so you'll get quantity discounts. There's a lot of benefits to standardization. And then the assembly line process is where a product goes through a line and workers work on it as it goes by. You think you've seen images in car factories that do that. So a couple different things about production methods. Flexible production, we talked about that a little earlier with intermittent production. That's where you can tweak the product based on customer demands. This is something that's happened in the car industry. So if you go on Ford's website and order a Ford F-150 pickup and you want certain interiors, certain colors, certain radio, all that kind of stuff, that information is fed to the production line, and they have a car designated for you that then they would do those items on that. A lot of times the companies will use programmable equipment, so if a different product is coming down the line, somebody doesn't have to stop and change the machinery. It could be very quickly changed to a different task or a different component. But you do need more skilled laborers in order to be able to do that. It's kind of the opposite of standing there and doing the same thing every day. So customer-driven products, that's where a customer's demand is what initiates production going through the factory. So a decision to say, what are we going to make today in our factory? It could either be driven by, we have an order from customer X, let's make that part for them, or it could be driven by the fact that we usually like to have 10 of these parts on the shelf and we only have 2, so let's make 8 of them today. So we're manufacturing to forecasted inventory, not to customers' orders. Generally, the trend in business is towards more customer-driven production, again, an effort to reduce inventory. So one thing about some strategic decisions about manufacturing, one is location. So where should we place our factory? One way to think about it is, where is the bulk of the transportation taking place? Is it bringing raw material to my factory? If I have a type of business, say a sawmill, where I'm bringing lots of trucks of logs into my business, and that gets manufactured down to a smaller volume of product that then gets shipped to end users, I might want to have my sawmill near the forest. So I'm minimizing the transportation of the bulky, large raw material to my factory. Other kinds of companies, if they need high speed to get their product to the customer, they may want to locate their factory closer to the customer base, so closer to large communities, that sort of thing. Other factors are energy supply. So a lot of computer chip manufacturers are located in Eastern Washington to make use of, and now server farms are located in Eastern Washington to make use of cheaper hydropower. Labor supply. A lot of companies will cluster in a certain area so that they then will attract workers that have skills relative to those industries to that particular area. Another strategic decision is how to lay out a particular factory. Most companies use what's shown there as A, which is they have different departments within their factory, and the product weaves its way through the building based on which different departments need to work on that particular product, which processes are required for that product. So some products may go through and may not touch all of the different portions of the factory, and others might. Another one is a product layout. That's where the product goes through the factory and workers and parts come to the product, but the product is moving down kind of like a spine of the factory or a central aisle in the factory. The example shown here is a car being assembled on an assembly line. Then the last type is a fixed position layout. So imagine construction. A Boeing airplane, where it's so large, moving it is difficult. So bringing everything to that central point is what's needed. And of course, your business could have a combination of these things for different parts of the product. So another decision to make is suppliers. So all businesses use suppliers to some extent. Some businesses use a lot of suppliers or really rely on their suppliers for pretty much everything. Other companies buy only raw materials and do all the other processes in-house. So the first decision is, are we going to do it in-house ourselves, or is it better for us to have somebody else make a particular part, paint our product, package our product, whatever the case is? So the key thing there when looking at suppliers is to judge them holistically, not, of course, to buy on price only, which some people do. Also look at differences in quality. Is every part identical? Can you rely on the parts you get from that supplier working in your product? Know that when a customer buys your product, they're buying a product from you. So if it fails because the supplier didn't meet specifications, the customer sees that as your problem, not their problem. So how reliable are they in delivering? So if I order products and I say I need them 13 days from now, because that's when I'm going to have a gap in my production that I need to fill with that product, then I want to know that it's going to be delivered on the 13th day, that it isn't sometimes the 20th day, sometimes the 5th day. I need to know when it is so that I can count on that. Cost, of course, is a parameter. And then another parameter is ordering. So can I order one at a time? Do I have to order in truckload quantities? How much lead time do they need to be given before they can supply it to me? Those are all different questions that I would ask if I was shopping for suppliers to try to make my best judgment as to which supplier would work the best for our company. A little bit about inventory control. So this really drives what a lot of companies do with regard to manufacturing. So it's important to talk about and understand. The intent is to have the right amount of inventory available right when you need it. That's the goal that we strive for. Of course, it's difficult to do that because you can't control the actions of other people. So they may not deliver on time, they may deliver early, that sort of thing. And you can't perfectly predict demand. So you might have a run on the product, a lot of customers might order it, that sort of thing. So the risk of having too much inventory, and I would argue that there's a greater risk of having too much than having not enough. So the risk of having too much inventory is that it increases your warehousing costs. The more inventory you hold in your warehouse on your shelves, the bigger building you need, the more warehouse racks you need, the more forklifts you need, the more people to drive forklifts you need, the more propane tanks you need, all of that. So the costs go up as you're storing more and more stuff. You also have a risk of the product becoming obsolete while it's sitting on the shelf. So the longer products or components are sitting on the shelf, the greater the likelihood is that you figure out a better way to make that product, or customers' taste change or something, and then you're left with product that you can't use, which is an expensive mistake. There's the risk of damage. The more stuff you have in your warehouse, the greater the likelihood is that somebody's going to run into it with a forklift, or it's going to fall off a rack or something. And then there is interest and taxes, property taxes that you pay on your inventory. So the risk of not having enough inventory is that you have a stockout situation. You go to the shelf, you need something, it's not there, you have to tell a customer that you can't fulfill their order on time. That's the downside. And if that happens, in extreme cases, you might lose a customer. So strategic decisions about inventory control, a lot of companies are using just-in-time systems. So they're trying to minimize their inventory, shorter production runs, and they're looking at all the activities that take place in their factory, and they're trying to eliminate any activity that doesn't add value to a customer. So moving stuff around in buildings on forklifts doesn't add value to a customer. So trying to eliminate that is important. So most manufacturing companies employ something called an MRP system, and I just want to explain it to you so that you'll know what it is when you come across it later. So MRP stands for Material Requirements Planning System. So it's a computer-based system that you put in all of the quantities of all the inventory you have in your system. You put all of your orders in the system that you have from customers, and then the computer system will tell you what problems you might have. You're going to run out of 1/2-inch washers. You're going to run out of 8-foot 2x6s. You're going to run out of screws, whatever the case is. And it projects out into the future when it is you're going to run out, and it suggests steps that you could take now to avoid those problems. So it's a way of using the computer a computer system to give you advice on how best to run your factory, and when to make purchase decisions, when to manufacture something, all of that. So each item in your system, every single the finished components, work in process components, and raw materials, for each one of those you will have an item that has an item number and a description in the system. You'll have an indication whether you make that part, which would mean it would register a manufacturing order, or you buy it from somebody, meaning it would shortage there would show that you should purchase that item. If you do purchase it, it would say who the supplier is and maybe who an alternate supplier is. It'll have the lead time and number of days. So if it says you're going to run out in 15 days and the lead time is 10 days to get it to you, it will tell you 5 days from now that you should place your order. It'll determine, you'll show here if there's a minimum order quantity. Maybe you have to order in lots of 24, a caseload, or lots of 100. You'll indicate where the location is, so where in your warehouse is that item found, so you can go get it easily. And then are there alternate items? If we run out of 1/2-inch washers, would a 5/8 washer work instead? That sort of a thing. So an MRP process is built on a bill of materials, or a BOM for short. So every item that's composed of more than one part is going to have a record in the database that says this is what this item is made from. And it's kind of like a recipe for making the product. So that's the key thing that's being used by that MRP process, because somebody's going to order something on the top level, a finished product, and it needs to go through and say all of the parts below that, where are we at on all of those? So an example here is a simple product my company used to make, this single bay 2 belt seat swing set with an 8-foot beam. So that was an item a customer could order. So that item was called an IS8 2BW. So that's an inline swing, 8-foot beam, 2 belt seats, and it was in the woodland color scheme. So that single product a customer could order was comprised of 2 M011 EWs, those are the uprights, 1 R365W, that's the cross beam, and then 2 H365s, which were the swing assemblies. Each of those items were then comprised of other parts. So this is an example of a bill of material for a pretty simple product. And of course, it could be much more complex than that. So a little bit about quality. So quality is defined as a product being free of deficiencies, essentially meaning that the product is what you tell the customer it is going to be. So quality doesn't mean that it's the very best you could get. It means that it's very, very close to what it is you're promising customers. So a lot of companies will use statistical quality control. So they'll gather data continuously about any problems that customers have with products, any defects they see in the production process, so they can analyze that and focus on the biggest problem first. So it's a kind of a different approach. If you hear the term Six Sigma, that's a company striving to make no more than 3.4 errors per million products. So a very, very high level of quality. There's an international organization called ISO that has quality standards, and if companies comply with those standards and then they're tested to see if they meet the standards, then they can claim ISO either 9000 for quality issues or ISO 14000 for environmental issues, so that customers can see that the company has a robust system for doing what they say they're going to do. So it's a way, if I were looking for suppliers for my company, I would look for companies that had that, that had achieved that status and had that certification, because it would tell me that they have the systems they need to have so that I can rely on them. So thank you for your time. I look forward to talking to you in the next lecture. Thank you.